Bonjour à tous, buongiorno, privyet. Today we meet to talk about Thymio and Python. We are very happy and excited, but first I remind you that this webinar is recorded. I will be shared on social networks. So it's up to you if you want to have your camera on or off. And if you have children next to you, be aware of this factor. And Sarah, for this webinar, we are very lucky because we have 5 speakers.
Yes, Sophia, I will begin with the introduction of each speaker and the content that they're going to share. First of all, we will have a video from Dr. Fanny Riedo from MOPSIA, our association, that has prepared to explain what Python is, why and how to use Python on Thymio, how to get started, the installation step, and the hardware offered by MOPSIA. Then we will have the Dr. Yves Piguet, who will present Python package for the Thymio 2, how it can be used to discover interactivity to robot features, how to run Python programs on the computer, to control the robot remotely or autonomously directly on the robot, and how our module fits in the programming environments Jupyter Lab and Tony. Then we will leave the stage to Moti Ben-Ari, which is a professor emeritus at the Department of Science Teaching of the Weizmann Institute of Science. In 2019, he received the ACM Carlstone Outstanding Educator Award. He's the co-author with Francesco Mondada of the book Element of Robotics. He will display a tableau of the content of the book. He will do a demonstration on Tony and explain why he prefers it. And finally, he will present a source code as an example in Python. Then we will have Vaucher Elliot. Is a resource creator for teaching computer science at the Gymnasium and Learning Center. He will present proof of concept of a Thymio program that scans tweets mentioning the word Thymio, performs a sentiment analysis, and return a final statistical value as a positive or negative, and then activates Thymio LEDs accordingly. So in other words, it will show how Thymio reacts to the kindness of tweets that are mentioning on Twitter. And then finally, we'll have Carl Turland, ECT professor at the International School of Lausanne, who will present a feedback of his school, his class, and how he uses Python and Thymio within his class.
Thank you so much, Sarah, for the introductions of the speakers. But before beginning, we remind you that you can ask any kind of question by the chat. And Sarah, she will take them and share with us at the end of the webinar. We will have a moment of questions and answers. And now we will begin with Fanny's video that she has made especially for us today. So Evgenia, can you share your screen, please?
Hello, everyone. Welcome to this presentation on how to program Thymio with Python. So what is Python and why use it on Thymio? Probably you've already heard about this because it's these days very much used, for example, in big data, or it's a widely used language. It's very accessible. It has a relatively easy syntax. It has numerous libraries and also a very wide community. So for all these reasons, it's very popular right now, and it can be very interesting for your pupils to learn and students to learn this language. So who can program Thymio in Python? At MOPSIA, we developed several exercises and examples with detailed explanations in several languages. Our goal is to make this accessible to students of junior high school and high school. So we try to provide a high level of detail. Of course, Python allows to make some very advanced programming or use advanced algorithms. And that is why we also have some courses that are more adapted for university students. In particular, the courses provided by EPFL are, of course, intended for university levels. So a little bit of context about Python. Usually when we have a program, it's an executable. It's an ensemble of instructions that can be executed by a processor, so in machine language. Of course, for humans, machine language is not very understandable, so we write in a high-level code, for example, C. We have a compiler, which is a program that will transform our high-level code into an executable that is then executed by the professor. So it just translates into machine language. It takes a little bit of time, but then it can be executed on its own without having the compiler available. In the case of Python, though, it's a little bit different. The Python code needs an interpreter to be executed by the processor. So the interpreter translates the Python code into machine language, but it does so in real time. So the interpreter always has to be here for the code to be executed. On Thymio, we do not have a Python interpreter because of the hardware, because of how Thymio was made inside. It's not possible to have an interpreter that is embedded on the Thymio. So usually what happens when we program Thymio in Asiba or other languages is that we produce an Asiba script that is compiled by the Thymio Device Manager. Thymio Device Manager is the program that communicates with the robots. And this program generates an Asiba executable, which is the language of Thymio, that can be executed by the Thymio virtual machine. So in the case of Python, we have our Python code and we have a Python interpreter that runs on the computer. So in order to make this accessible to Thymio, a module was added to the Python interpreter called TDM client, which communicates with the Thymio Device Manager. So it can send instructions directly to the robot through the device manager, or it can transpile the Python code into a Asiba script. So transpiling means translating Python code into another high-level language, Asiba script, which is then compiled by the Thymio Device Manager and generates an executable for the robot. How to install everything you need to program Thymio with Python? The first step is, of course, to have the Thymio Device Manager, so Thymio Suite. In order to do this, you will go on the Thymio website in the Download and Install section, and you will be able to find installers for different operating systems. Windows, Mac OS, or Linux. You can just choose it from there and install it on your system. Then, of course, you need all the Python interpreter and tools. In order to install this, you can just go on the Python website, and once again, in the download section, you will be able to find installers for different systems. Once this is installed on your computer, you will also need the module that we mentioned before, TDM client. So this will be actually installed directly from the Python command line. If you want to use our documentation, which is in the form of Jupyter notebooks, you will need to install Jupyter. In order to install Jupyter notebooks, you will need to use a command line. You will have to type a series of instructions. In order to do this, please follow our guide, which is available on our website. And once this is done, you will be able to use Jupyter. I will tell you a little bit more about Jupyter notebooks. So what is a Jupyter notebook? I will show you one example. A Jupyter notebook looks like this. It's a document where there is text and also code. There are different parts which we call cells. For example, the first part here is a text cell, so a markdown cell. If you double-click it, you can see the source. So it's text with markers. And then if you press the play button, it will be executed and show its final formatted text form. Then there are cells which contain code. So you can see these lines of code, and if you click execute, then this line of code will be given to the Python interpreter. So this one in particular just installs our module TDM client, which I explained before. So every time you start your interface, you should execute such a cell to make sure you have the latest version of TDM client. Now, once everything is installed and you want to start programming, you need to execute the following steps. First, start Thymio Suite. This will start the Thymio Device Manager, which allows to communicate with the robot and the Python interface. So it's enough to just start this window and keep it running in the background. It should always remain open. But if you want to see the list of connected robots, you can click on whichever one of the programming interfaces are available, and it will display the list. So at this moment, there is no Thymio connected. So of course, the second step would be to connect the robot. So here I'm going to connect it with the USB, and now you see it appearing in the list. Once it's connected, it can be selected. It could be programmed with the ASIB interface, but now we're going to use Jupyter. So first step is to start the command line and then type the command Jupyter Lab. This will start the Jupyter Lab interface. Actually, Jupyter is a web-based application, so it will start as a tab in your browser. So you see now I have the app running in browser. So this is the first notebook, the Getting Started with Thymio on Python. This notebook gives you an overview of all the instructions you need to execute to connect to a robot, and also all the API. That means all the functions that are available and that you can use to access the Thymio's functionalities, the sensors, the actuators. And you will find examples for each of the sensors and each of the actuators. So as I mentioned before, you need to execute the first line of code in order to install the TDM client module and make sure you have the latest version available. So keep this cell always in your notebooks. And then the second cell containing code actually has the commands that allow to import the necessary module and then to connect to a robot. So if you have a robot available, you see now it's grayed out. So it means that it was connected to the Python interface. It cannot be observed in ASIB Studio, but it cannot be connected to another interface. So it means I can start executing instructions. I can either execute instructions to access the robot's variables directly. So for example, here I'm going to measure a value and return it. I'm going to measure the value of the horizontal proximity sensor and then print it to my screen. If I execute this cell, you will see it returns 0 because there was nothing in front of the robot. And if I do it again, this time I place my hand in front of the robot, you will see a different results. See, now it measured the value. Now, of course, we can execute bigger programs. So you see this bigger cell underneath. It starts with the command run ASIBA. And underneath, I just wrote ASIBA code. So if you have already learned the ASIBA syntax, this will be very familiar. It's the native language of Thymio. So this is a program, a complete program contained within a cell. And thanks to this run ASIBA line that is in the beginning, it will tell the Python interpreter to send this program to. But then, of course, we want to program in Python. So underneath, I have the same cell, the equivalent of the same code, but in Python. And you can see executed. So first, I can show you my robot. Right now, it's not programmed yet. So if I click the buttons, it doesn't do anything. But then if I go back to my interface and I execute this cell in the code, then you can observe on my robot, now it's doing something. Each button has a color assigned to it. So, thank you for your attention. This was a very short introduction on how to use Python for Thymio. And of course, my colleagues will be here to answer your questions, and they will do some other demonstrations. And feel free to contact us if you have any questions. All the material I showed are downloadable on our website. Thank you.
Thank you so much, Fanny, for this nice video. Fanny asked me also to share with you one link where she has a folder with documents. So I share on the chat. And now we are going to give the floor to Yves. Yves, are you ready? I think you are.
Yes, I am. Thank you. Thank you. I was clicking the share button. Didn't do it. I couldn't undo it. So here it is. Can you see my screen?
Yes, we can see your screen communication between Jupyter and the Thymio.
Thank you. So I will continue with what Fanny explained. With this, use this Jupyter Notebook interface for text and for execution of Python code. So maybe a word of background. about this package for Python, TDM client. The initial idea was to connect to the TDM, to the Thymio Device Manager, which is this part of Thymio suite which communicates with the robots on one side and with all the clients you want to have, programming environments such as VPL or the Azeba Studio, where you can program with the Azeba language, or Blockly or Scratch. So TDM is the piece between the robots and the programs. And with TDM client, you add the possibility to program.
Yves, sorry to interrupt you, Yves. Do you hear me? In fact, yes. We have some problems with your micro. We have a problem of sound. We don't hear you very well.
I will. Is it better?
Yes, now it's better. Thank you, Yves.
Okay, I will continue like that. Sorry. So I was saying that the Thymio Device Manager is the piece between the robots and the programming environments such as VPL or VPL3 or Scratch or Azeba Studio. And TDM client is a module so that we can connect to the robots directly from Python. And the idea is we want this module or this package to be very modular so that you can send commands directly to the robots if you want to control it from Python with your program running on your PC. Or we can also use the transpiler to convert our programs from Python to Azeba, to the Azeba language, as Fanny explained, to run it autonomously on the robot. So for some cases, it's better to have the program running on the robot. For instance, you can have a much faster feedback loop. If you want to follow a wall, you will measure the distance between the robot and the wall with the proximity sensors. And you have to react very quickly to keep the correct distance by acting on the motors. And for other applications, you want to retrieve the data from the robot and process them in Python on your PC. Because on the PC, you have access to all the standard packages available for Python. And you have a lot of processing power, which you don't have on the robot. Or you can access to the internet or to files, for instance. And we also provide different programming environments with TDM client. You can use it directly from the terminal in the simplest access to Python. Or you can use Tony, which is maybe more suitable for kids, or the Mu editor, which is a little bit similar, but another program similar to Tony. And you have also Jupyter, or you can run Jupyter notebooks also in Visual Studio Code, for instance, which is maybe better if you want to debug programs. If you want to run programs on the robot itself, you must be aware of what is done. So basically, we translate Python to the Azeba programming language. So you keep the restrictions of the Azeba programming language. The differences are explained here. So we have a Python syntax instead of the Azeba syntax. It's the most obvious change, of course. But we keep the same data types we have in Azeba. So we have signed 16-bit integers. And we have arrays, which are called lists in Python, but which must have a fixed size. Then we remove the restriction which exists in Azeba, which is that we have a clear distinction between Boolean values and integers. So we can store the result of comparisons into variables, for instance. We can use them directly in if or while statements. We have a print statement, which is very useful when you develop a program to check a value in your code. We replace subroutines in Azeba with functions, which are much more powerful. We have local variables, we have arguments, and we have return values in functions. And the on event is basically the same, except that it's defined as a function. So we also have local variables, and we must take care of global variables if we need them. And we don't have the when statement. I won't explain why here, but you can ask later if you're interested. So just, I will skip quickly here because Fanny explains that. So usually we start the Jupyter notebooks with the statements here. And we can synchronize. So when you use a variable which has the same name as a variable on the Thymio, the values are shared. So in one sense, for instance, if I execute, so I have to execute this cell to import everything. But then if we execute this cell, we print the value which comes directly from the Thymio. And if I put my hand, unfortunately, I have only two hands. So with my mic, it's a little bit difficult. But okay, I've put an obstacle in front of the Thymio. When I execute this, it was a black obstacle, so it doesn't work very well. But once more, so here, my Thymio connected to the TDM client sees another white Thymio. And we can also, when we change a variable which is recognized as something, as a variable on the Thymio, it will be synchronized back to the Thymio. So here you can see that the blue LED, the top LED was switched to blue. And we have the print statement. So here, for instance, we can run this in a timer. And if I put my hand in front of the robot, you can see that we read the values. Here we should stop the execution with this Jupyter button here. I will skip a little bit so we can exchange data also with events. Events are what is used on the Thymio, for instance, to react to presses on buttons. But we can also use them to exchange data between the computer and the Thymio. I will maybe just switch quickly because time is limited to working with other devices. So here I have an example with using a gamepad. So I have a gamepad, which is a USB gamepad, which is connected to my computer. And if we import the relevant Python package, we can check I should disconnect and reconnect the gamepad for each.
Just Steve, you have here, 1 extra more minutes.
Okay, thanks. So here you can see that we can have the values of the joysticks. I have 2 joysticks on the gamepad here. And we have buttons too. And if we have here this small program which runs on the PC and which communicates with the TDM, with the robot via TDM client, we can send values. So I will switch directly to this program here. And now when, I don't know if, I will put the mic near the robot, so maybe you cannot see it, but you can hear it. So when I move the joysticks here, you can hear the robot moving. That's it for the moment. Thanks.
Thank you so much, Yves, for your nice demo. And now we are Moti, but don't forget to ask all the questions to Yves by chat. He will be pleased to answer you at the end of the webinar. So Moti, are you ready? Where are you? Maybe Yves, you can stop your screen sharing.
Okay.
Perfect. Now we have you, Moti. You can begin.
Okay, do you have the screen share yet?
We don't see your screen. We only see you.
Now you can?
Yes, now we see your screen with the motor time scale. Yes.
Oh, okay. I worked for about 5 years together with the people at EPFL and Francesco Mondada's group on the Thymio. My specialty is computer science education. So I've been involved mostly in writing tutorials, sample projects, and things like that. I really like using Python for a reason that's perhaps hasn't been mentioned so far. And that is that what you can do in Python, you can also do on a regular computer, not just on the Thymio. So for example, I have a computation here where I want to see what the best scale factor is for computing a distance. And I can run it, here we are, on a normal Python, as a normal Python program, or I can run it on the Thymio itself. Well, I can't do it because it's been disconnected somehow, but it should work now, hopefully. Yes, okay. So this is why I am very excited that Python is now available. I use the Tony environment because it's very similar to any other program environment that you may have been using to learn Python or Java or any other programming language. I have now written a short tutorial on programming Thymio with Python, giving you just enough information to be able to do all of the standard problems or all of the problems that a student would like to do on the Thymio. Explaining how to install it. I have a very long example program here where I explain all the programming possibilities in the Thymio and some of the features that you have with the Thymio native functions and so on. Can you see me here? Can you see my Thymio?
Yes, we can see your Thymio, Moti.
I'll stop sharing for a minute.
Yes, I will épingler you.
Okay, here, what I have programmed here in the, that I'll show you sooner that you have in the tutorial is the Breitenberg vehicle dogged behavior. It's very similar to the green and orange behaviors that are pre-programming. And for example, I always try to use the central button for turning it on and off. And well, I probably turned it off. No, I'm sorry, I didn't run it since it was. Okay, it should work now. And what I like to do is I like to use the top node LEDs, especially the colored ones, but especially the circle nodes, because you can use these to display a numerical value. You can display 1 to 8 normally, or you can even display in binary up to larger values. Okay, here is the program again. And as I said in the tutorial, you have a full explanation of what is going on here. Another thing you can see is that, see, I print out the value of, well, it's pretty hard to see now, but you can try it. I print out the values of the sensors so you can follow what's going on and try to debug it. Now, one of the main things I did with the Thymio was, together with Professor Mondada, we wrote a textbook called Elements of Robotics. It's published open access with Springer, so you can download it for free. And the concept behind this is that I found a large gap between the types of activities that kids in school do with something like the Thymio. But when I started looking at more advanced robotics textbooks, you need like to finish a university course in engineering or mathematics to understand it. But what I found out is that the Thymio is really, really an excellent robot because you can demonstrate very advanced concepts in it, even though you can't really do it like a real professional robot. So here is the table of contents, and you can see I can demonstrate things like obstacle avoidance, localization, mapping, fuzzy logic, neural networks, machine learning, and so on with the Thymio. Now, this is not, this is only demonstrating things. For example, let's see here, I'm doing something in imaging processing, corner detection. Now it's really not really something advanced because it's sort of one-dimensional processing here, but the filters I'm using here and that you can learn are real actual filters used by professional people in image processing. Another example would be, this is a neural network using what's called Hebbian learning. Again, it's very simple, but the concepts, the advanced concepts are also there. My favorite one was this one, which is... Sorry? Okay, this example, can I continue?
Yes, you can continue. Sorry,
okay.
We have a noise problem.
Okay, this is Markov localization, a probabilistic method, really an advanced method of doing it, of trying to figure out where the robot is. And again, it's being done in one dimension. So it's not something you would use in a self-driving car, but the concepts are really the same as what you would see in advanced textbooks. Now, even though the book was not written as such for the Thymio, nevertheless, of course, Professor Mandada is the leader of the team that developed it, and I worked on it for many years. So the textbook is Thymio compatible. And we wrote about 70 different activities in Thymio in Aceba for running these activities. And what I have now done with the excellent help from Yves, of course, is to translate these all into Python. So they are now available also in Python. And I would really hope and invite you to look at them, try to improve them, or try to use them as inspiration for other advanced projects and activities that can be done with the Thymio. I think I still have some time left, but I'm out of things to say. So.
Thank you so much, Moti.
Yeah.
I share with our community your link of the books Elements of Robotics on the chat. And we also shared the material on Thymio, including the Python tutorial also on the chat. Thank you so much for this sharing, Moti.
Okay.
And now we are going to let the floor to Elliot. Elliot is here and share with me the space on the open space. Are you ready, Elliot?
Yes, I am. Can you hear me, everyone? Yes, okay. So I will present you another perspective on using Thymio with Python. I actually come from the art curriculum, so my take on Python and Thymio is a little bit less an engineer take, but I hope it will be interesting for you. So I will start with a quick video that displays the program I wanted to use with Thymio. Can you see the video?
We can see, yes.
Okay, so it's only a recording of the program running on my laptop. I didn't want to do it live because I'm too afraid of eventual bugs. So here, what you can see is that the program ran and it gave an output that gave a kind of a statistical percentage of positive tweets that had the Thymio mention in Twitter. Here you can see the tweets that were parsed. Okay, so now I will share a presentation to continue. So I just have to share another screen for the presentation. Here it is. You can follow along if you want. I will give you the link in the Zoom. Okay. So here it is. And also on the presentation, you can find all of the source material. So you have the links for the Twitter account, and all of the sources are for the GitHub account, and all of the sources are here. So what I wanted to do was really a proof of concept. So it's not a program that could be deployed on a production level, but it's actually working. And the idea was to give Thymio a kind of artificial intelligence, but I wanted to be emotional, so to speak. So here are the links for the GitHub pages, GitHub repo, and the demo I just showed you. What were my research questions? Well, I work at the EPFL in the Learn team as a bridge, so to speak, between college level computer science and art, because my curriculum is previously in art. And I wanted to build something artistic with Thymio. And I'm also very interested in artificial intelligence, but again, the term is maybe a little bit too much for what the program really does. The principles I had in mind to build this program was that, well, obviously Thymio comes from the Greek word thumos, which means emotions. So, well, as it always plays with emotions, like all of his basic behaviors are linked to this name also, but I wanted to stay into the scope. And I also thought that Thymio should have a kind of brain that's different from the sensors, the physical sensors he already had. My basic concepts were that intelligence is somehow something like information processing. Autonomy is something like reacting to events in real time. And I also thought that Thymio already had physical sensors, so I wanted to give him kind of information sensor. And my question was, what if he could understand the meaning of words? The methodology is one of hackers' perspective methodology. That's to say that I'm not an engineer, so I think there are lots of problems in my program. I just took many things that Yves wrote in his notebooks about Thymio and Python, and I just like kind of put them together. I used a library in Python which is called TweePy for working with Twitter. So you can just actually discover this library. It's very well written. You can just make some calls to the Twitter API very easily. Yeah, I just like bridged many things in my program and then prayed it will execute at the end, and it actually does. The details of the program quickly are the following. So basically the program just authenticates, goes to Twitter to see every tweet that mentions him, performs what one could call sentiment analysis, but it's like really just looking for a polarity in the words used into the tweets. Then it categorizes the different tweets, and it calculates if there are more positive tweets than negative ones, and then it activates the LED. So what I'm actually I actually think it's kind of funny in the moment is that all that was presented before was how do you interact really with Thymio, and in this program the only thing that really interacts with Thymio is the activation of the LED. But again, it's a proof of concept that with a Python program we can talk with Thymio. And the enhancements, of course, are to perform better sentiment analysis. If you go into the source code and you look at the results of the program, it's not that precise, and it's like it doesn't perform well on French language also. So I should add a French module to it. And the sentiment analysis is not that good. So this could be enhanced, of course. And also a lot of other bugs that could arrive if I really tested the program for a production scale. And yes, so the conclusion is that I wanted to give a kind of artificial intelligence to Thymio, but then I thought of this artificial emotional intelligence word, and I found it quite cool. Okay, I hope you liked it, and if you have any questions, please.
Thank you so much, Elliot, for your beautiful presentation. So Elliot, share on the chat the presentation that he just shared. Please, if you have any kind of questions, don't hesitate to send to Sarah by personal message or by general message, so Elliot at the end can answer to the questions. And now we are going to give the floor to Carl. Carl, who is in his classroom right now. So hello to all the students of Carl, and Carl, the floor is yours.
What? Excellent. Okay, so let me just share the screen. Okay, can everyone see that okay?
Yes, we see your PowerPoint, yes.
Fantastic. Okay, so I'm a teacher at the International School of Lausanne, and I teach IB, NYP, and diploma programs. We started with the Thymio for the first time this year as a new project, and it was used at year 11 level, which is students aged between 15 and 16. So the reason we got into this, actually, two of my students set up a girls' coding weekend, and we had Fanny and more involvement as well from EPFL, who supplied the Thymio robots for us. And we ran part of the weekend that we ran had a workshop using the Thymios, and it was used as an introduction to robotics. And the reception we got from the students was really positive. So after this event, we decided to invest in our own class set of Thymios, and then to introduce it into the curriculum for our year 11 students. So the main part that we were really focusing on for this was input and output, conditionals, loops, and functions. These are the skills that have been taught to the students at this point. And it was taught as a formative unit. And in this way, these are units where I expect students to experiment and take risks without fear of the kind of assessment coming afterwards. And I find with these kind of robotics units, it tends to work quite well. So each week, students were randomly assigned a partner in a class. So they had a complete mix of people they were working with as well. And this year, and possibly next year, we're not sure yet, it was taught alongside another piece of software called CoderZ. So the CoderZ software is also robotics, but it's completely software-based. So students were quite often using this initially and learning a concept in robotics, and then we would try and apply the same concept and problem solving with the Thymios. So the Thymio, every lesson, when they had a Thymio session, they were given challenges that they had to complete. And we had the basic Python documentation that was supplied to us, which was really useful to get the students off the ground. And yeah, it was pretty successful, actually. I think they found the idea of the changing of syntax was quite confusing at times between some of them, between CoderZ and Thymio. But we had a lot of success in the classroom with the Thymios. So to give you some idea of the kind of challenges they had to do, these were a little bit later on. But this was the 90-degree turn one, which again was initially completed in CoderZ, where they had to try and find a target, try and turn 90 degrees to complete the course. We then went on from there and then had a setup where they had to try and detect when there was a turn on the right-hand side. So they were using the front sensors to do this. I'll play the other one first. You show the kind of progress that we had, where we had quite sharp turns that were implemented initially with using the Thymios, but then these were slowly bettered over time to have more kind of gradual turning algorithms for the Thymios. So after that, the main final challenge that we had was a race day. and we made a model of the Spa racetrack in Belgium. And the idea was that students had to produce a line following robot to get around the track as fast as possible. So this was built up over a number of lessons where they initially started with just some black tape and they were setting up their own tracks on the tables. And then they had a practice race day where we actually got the racetrack out and they were given time to then see if their robots could get around the track. And this is what you're seeing in the video now. And I thought there was a real progression here in terms of how I wanted kind of like an open-ended challenge where I knew they would approach it in different ways. And that definitely was the outcome. The students, many of the robots were not, using the same ideas or concepts. Rather than using both of the ground sensors to actually detect the lines. I don't know if you're getting that internet connection is unstable as well message. There we go. So the final race day was then held, and then they were given each 2 runs at the track with the fastest times taking the award. So the future for us, I mean, this was very much our first year of introducing this, and it was definitely a success. We definitely want to expand on the program. Possibly next year, taking out the other side of it, the software side, and sticking with more of the practical. I would like to add another big challenge, a bit like the race day, and actually have 2 different projects they have to work towards. So we're kind of thinking maybe communication, where teams would have to communicate between 2 robots, or possibly like an obstacle challenge, which we had used at the Girls Coding Weekend. And another possibility is with the Lego components that you can connect to Thymio, trying to bring some of that into it, maybe with the 3D printers to bring in another challenge for collecting objects or something similar. So from our experience, and I say this is using it with quite younger students as well. So I'll go from the negatives first. I'd like to finish on positives, obviously. So I thought we found the setup was a little bit difficult for the students at this age. They had some experience normally using an IDE like PyCharm, but actually setting it up for the Jupyter Labs was a little bit, it took a good lesson and probably about a whole lesson really to get everyone up and running. Now, I think the next point, I'm not sure is true now, because I saw actually when Yves was showing some of his programming, that some of these functions were working for him, but we couldn't actually get for example, just standard Python functions working as we were doing it. So that we wanted to get random integers or casting integers, and we couldn't get that working for us. Some of my students said they would like it to have more than 2 timers. It was the first time they'd used Jupyter Lab, so that whole different IDE environment took a little bit of time to get used to. And from my point of view, just the turning off and the turning on of the Thymios, because I found that when I plug them into charge, even if they're turned off, they come on. So if I'm doing 20 Thymios at once, I ended up having to turn 20 Thymios off each time. And then at the same time, the moment I turned the charger off, they all again would switch on automatically. So I ended up having to turn 20 Thymios off. But the positives definitely outweighed the negatives. The students were very engaged, and when asked, which unit, the Coda Z or the Thymio one, hands down. The wireless setup, considering we had 20 students all running them at the same time, we never had any issues with that, which was great. We found that there was a really excellent level of problem solving from students. And as I say, it's completely unanimous that the Thymio was much more fun project that they really enjoyed. And yeah, the response was excellent. So yeah, hopefully this is just a start for us. And we look to really develop this, and some of the resources I've already seen that have been given by others here, I'll definitely be taking a look at to expand our project and make it even more engaging for students. And I'm sorry, I've probably gone a little bit under my time there, but I think that's all I've got to say as well, unless there's anything.
That was perfect, Carl. Thank you so much for your nice presentation. And I think that it's very important for our community also to celebrate, failures and negative points to improve ourselves. So that was super nice of you. And now we are going to go with the questions. Sarah, did you receive questions that we can ask to the speakers?
Yes, the first I received, first of all, thanks a lot to everybody for this nice presentation. I was really impressed, and thanks a lot again, Carl, to be our speaker, because it was really nice as well to see an example, you know, in a real class, how it was and what was the challenge. So first of all, I would like to ask Yves, I received a comment on the chat while you were speaking. From actually I don't remember from whom, but I remember that somebody asked, where do we get that code from for the controllers? Do we have to install Jupyter? Can we run in Visual Studio versus Python?
You mean the user of the gamepad?
Yeah, maybe the person who wrote can take the
Yeah, that's
Ah.
Hi.
Hello.
Hi.
Nice to see you.
So I'm an assistant professor of computer game design. So and Sarah and I just been collaborating. So the robots are arriving later today. So
that's great.
Exciting. Yes. So I mean, seeing all these presentations from Moti to the art. I mean, this is like, my mind is just like, I'm kind of freaking out because it's like I want to run across campus and tell the dean like I've seen the future. But anyway, I won't do that yet. So like I also teach game design, so I was intrigued by the idea of the gamepad, because I mean the connection point there is really rich. But I use for the Unity game engine that I run, and we use Visual Studio and C#. So I was wondering, it would kind of be nice to have that development environment to do that, just as even a test piece. So I was wondering if that could be translated into Visual Studio, because that was awesome. So, I mean, and all the other stuff is cool too.
So in Python, in Jupyter notebooks, there is a library which is IPyWidgets, which includes the controller. This is a standard library for Jupyter notebooks. And then you can synchronize inputs or things between different widgets. And this includes physical things like gamepad. So I use this to connect to the Thymio with the TDM client.
Can I translate that code into Visual Studio though, or is it just have to run through the Jupyter notebooks?
Yes, it's the package itself is specific to Jupyter notebooks, but in Studio Code you can actually use. It's compatible with Jupyter notebooks, so you could use a notebook. I'm trying to put the notebook itself on Roteco so that you can get it and see how it's done.
Right. I got Moti's email. I mean, you might be hearing, everyone that presented might be hearing from me. So this is great stuff.
Yes, please, Moti, you can take the stage and reply as well.
Yes, I just wanted to say that I would be very happy to help anybody who wants to translate the tutorial to other languages. It's written in LaTeX, which maybe not everybody knows, but I'd be happy to help.
Thanks a lot, Moti, for your help. And I think there are so many people coming from different countries that will be glad. Maybe we will share anyway your contact at the end of the webinar with the people that are interested and they wanted to see again the webinar. So I would like as well right now to ask another question about, it's a technical question about Python. I don't know who would like to reply on that. Would be possible to run Python remotely without, it was actually a question that I had from Evgenia. Evgenia, you wanna ask yourself your question?
Of course. So it's interesting for me. If it is possible to have to use Python during the remote connection with robots, as we use for R2D2. knowing that Thymio sheet now proposes this option of remote control, is it still like possible to use during RTT2 missions? Thank you.
So maybe I will answer to that. So yes, it's possible to specify which TDM you want to connect to from TDM client. So if you have Python running on some computer somewhere, you can specify the IP address and the password which is used to prevent connections from people you don't want to access to your setup. But then you have to be able to reach the TDM program running on your computer. So you have to have a network which is open to outside connections.
Okay.
Another way, we are investigating other ways to do that without opening. So the problem is that if you, for instance, if you are at home and you want to permit people from the outside to connect to your setup, you have to open ports. You have to, there are some mechanisms on the router which weaken a little bit the security of your system, of your local network. So we are investigating other ways to do that, which will be safer. But right now, it's open to everything you want to do. You have the full capabilities of Python, and you can use, you can open sockets, you can do what you want.
Thank you.
Thanks a lot.
I will contact you if I would like to test it. And if I have questions, you know.
So thanks a lot, Yves. Thanks a lot, Evgenia. And right now, I would like to ask you another question that came from the chat directly to me, to Carl, because it was quite interesting what you did with your class. And first of all, what we would like to know, what kind of what was the most challenging part for children to use Python on Thymio at the beginning, and children, actually students in this case, and what kind of I mean, what kind of classes you did that to prepare them before?
So the students had nearly 2 years, well, a year and a half of programming classes up until this point. Mm-hmm. So that they, for their age, I think they're quite experienced coders, but they had progressed from kind of basic kind of online IDEs and had just moved into using PyCharm this year. So they were just getting used to kind of that IDE. So then the transfer from that to the Jupyter Labs was the biggest, and obviously the way that the cells and everything work in Jupyter Labs compared to a standard Python project was their biggest hurdle to kind of get over initially. But after that, it was, and I say maybe we were doing something wrong, because we were trying to, for example, import the random library and to generate random numbers. But we found that a lot of the standard Python functions wouldn't work in the cells when we had kind of declared them as Thymio cells. If they were just standard Jupyter cells, we could get it to work. But if we were trying to cast a float to an integer, it would return an error. So I'm not too sure what we were doing wrong there. But that was the main thing. So some of the skills kind of, or techniques that they knew, they couldn't apply to some of the projects on the Thymio ones.
Okay.
But in some ways, that's quite good, because it was a good problem-solving exercise for them. So they had to find ways to get around it. So. That's
great, actually. But anyway, I don't know if, do you have any reply about that? Or maybe what is the problem he had, or maybe Moti?
So maybe on the Thymio itself, you have all the limitations of the Azeba programming language, basically. So you are limited to integers.
In fact, there's a native function library that helps with the mathematical functions like sine, cosine, and things like that, but they're all done in 16-bit integers. So you have to do a bit of manipulation to keep yourself from overflowing. I've got examples in the book in some of the projects, and it's not fun, but it can work.
Okay. Yeah, that book looks really interesting. I'm looking forward to looking at some of the challenges in there and trying to implement them.
Thanks a lot. Thanks a lot, Moti and Yves. And Carl, another question, just the last one. I mean, last two. I have two right now. Okay. First of all, if how we could, where we find what you did with your students. Do you have anything written that we can share with in order, you know, for other people maybe to have some leads and you know, start with that maybe. You know,
I mean, I've got some slides that I use with the students. Obviously, I kind of have quite a bit of a teaching element to that, which is not present on those. But I'm more than happy to share what I've got so far. Mm-hmm. Yeah, I'll put them in the chat. Okay, that's great. And the last question is, there is the professor who was speaking before from US was asking me. What you're thinking about doing with the 3D printing or Legos and so on. What do you have in mind? Because you would like as well to, you know, to go forward with this project and, you know, pick up some ideas. A lot of my kind of initial ideas were actually from the Thymio video that you have on the main website. With there's quite a few creative uses of the Thymios. And yeah, I mean, I think the initial idea will be more of like an object collection algorithm where they necessarily have to go and collect objects and pick them up and move them to a certain other areas. That was the initial plan. But as I say, some of the Moti's ideas looked more interesting than that, to be honest. So maybe we'll change that to a different direction now.
Okay, that's great. Thanks a lot, Carl. And right now, I would like to ask you a question to Elliot, which for me was really interesting what he did, and not coming from an engineering world, actually, it's quite impressive as well. And Sophia wanted to ask you a question, and I will let her.
Yes, Elliot. So the question is, to which point, in fact, the analysis of the emotions is precise?
Yes, it's not that precise. And I've heard a speech on the exact same library, so TextBlob, to perform a sentiment analysis by someone who's really into the field, and he's working with media and journalists to try to gather information about like what tweets can imply for like ONG or big organizations. And he was working with the committee of the Red Cross, so the CICR. And yeah, he was just basically stating that it's very hard when you analyze the text of a tweet to see if the negative comment apply to the actual like organization that's mentioned or not. So if you had a comment like hashtag CICR, and then the comment would say it's an awful situation in Ukraine or anything like this, the sentiment analysis would actually say that it's a negative tweet. So those kind of bottlenecks arise quite quickly. So what I was showing is really a proof of concept. And if someone wanted to develop and enhance this application, one should really take more time to see how the analysis is performed. How could we use machine learning models to perform better analysis? So yeah, that's the limitation of this actual library.
Thanks a lot for the reply, Elliot. Very nice project, actually. I think we are running out of time. What we are going to do, we're going to leave the space for announcements. And then if somebody else wants to take the lead and ask the question to our speakers, we will stay a little bit longer in order to do that.
Thank you, Sarah. Do you see my screen?
Yes.
Yes, so just a short reminder. So all the webinars that we have done are on the webpage of Thymio. We have some webinars in French, some in English with different thematics. For example, programming Thymio with iPad, activities from elementary schools to universities. We also have videos in Italian, German. So don't hesitate to go and see what we have created until now. So that's the first announcement. The second one is the MOPSIA team. They have developed this behavior of Thymio like a bee-bot. So that is for more small children, but it's good that the community of Thymio knows this new novelty. I don't know if we have a lot of participants here in Switzerland, but in any case, we are going to meet physically at Ludovia Yverdon-les-Vins. And here, Sarah and Flora from MOPSIA will have one workshop of how to use Thymio with Scratch. And me and Evgenia, we're going to have another workshop presenting resources from Unplug until the use of Thymio for admission. We also wanted to invite you to the next Thymio webinar. It will be on French regarding the unplugged activities using Thymio. It will be the 4th of May from 4 to 5 as always, and by Zoom. So we are more than happy to welcome you. And the last announcement is that we are having a contest for teachers that want to participate in sharing material using robotics, any kind of robots. It can be also Thymio, of course, to teach math. So if you have one resource that you want to share with us in Roteco, you are more than welcome, and you can win nice prizes that you have here. We are going to share on the chat all the links. And now I let the floor to you if you want to take the floor and ask your questions orally. Mm-hmm.
Yeah. If anybody wants to take the stage and ask the question directly, it's the time to do it. Otherwise, we're gonna let our speaker go.
I forget to tell, sorry, thank you, Yves, for the reminder that Yves, we are going to put the resources in Roteco. So that's a good reminder. Thank you, Yves.
Maybe I have a quick comment, if I'm allowed to give.
Sure.
Thank you very much. We were waiting for Python support to come up for Thymio. But what shocked me a little bit is the many software systems that are involved and the complexity. As you might know, we are trying to use Thymio in the very basic digital literacy field, which means very, very beginners to programming and to robotics as well. And to me, it looks quite a big initial effort to install all this software system and to bring them all to work together for beginners. And I mean that you have to install a notebook, that you have to install libraries, start different daemons that translate, and then start a Python development system. So there is quite a bit of complexity that I don't quite see in general school use. And this will be a real challenge to get that stuff simplified. I mean, to us who are programming language experts, this is nothing. You know, we know how compiler, we know how interpreter, we know how virtual machines and everything works. But to have this in general schools, we somehow have to find a way to abstract it and to hide it.
First, for introducing the Thymio to schools, I recommend starting with the visual environments such as VPL. We've done that even in second grade, which is too early, but that will at least get you the Thymio installed and working. Now, I found that if I use the Tony environment, it's just one quick installation and one option to set within the environment. So it takes just a couple of minutes and it's no problem. Perhaps you can't do all the advanced things that Yves has programmed there, but it's enough for school children who have some experience in any programming language, such as Python. Working on a computer, going over to the Thymio should not be a problem.
Yeah, I think that could work. I mean, I saw Tony, and which is something that is used by many schools for elementary Python.
Yes.
And I think that with that one, we could then do this as a base. And of course, for us, Thymio controlled by the computer is all right. We don't have to use the option of downloadable code into the robots. That's probably something that you want, that you will need when you want to do advanced stuff like swarm robots or RoboSoccer or something like that, that you have to download codes there. So with VPL, the acceptance in schools is usually there for Scratch and for Python. And as soon as you're talking something else, the school teachers sort of don't know it and don't want to know it, which is unfair because some little languages can be very simpler than the well-known stuff. But that's a difficult thing to communicate to teachers, that they do a special purpose language for something that's very hard then to get them to do. But I think I mean, we will seriously try it. We will have we will actually do a product with Scratch first, and then probably do the Python product as a second thing. So, okay, thanks a lot for the hints.
Thanks a lot, Thomas, for your question. And thanks a lot, Moti, for the reply as well. Is there anybody else want to take the stage and speak to our speakers, to the people here?
And thank you again for all the speakers, because your involvement really make our community alive. So thank you, Elliot, Carl, Moti, Yves.
Fanny, which is not here.
Fanny, exactly. Well, if we don't have more questions or anybody that wants to take the floor, I will stop the recording now.